Chapter 8, Developing Network Strategies. This is always a fun chapter. So our author had a 12-step program. First, identify network assets, analyze the security risks to those assets, analyze security requirements and trade-offs. Big part of section 3 is every security requirement will have trade-offs. How available versus how secure is always one of the trade-offs. Fourth, develop a security plan that is realistic. Once we have a security plan in place, we can start thinking about defining individual security policies. Develop procedures for applying those security policies. 7, develop a technical implementation strategy. Just because we have a security policy and strategy doesn't mean that we're going to have the feature set to install the technical components of that security program. For example, install firewall. Okay, that's pretty straightforward, but do we have the technical capacity or the technical knowledge in order to properly implement that firewall within our overall design? That's why step 11 or step 7 is there. Step 8, achieve buy-in from the users, the managers, technical staff, and all other stakeholders of the organization. You have to have everyone on board in order for these programs to be successful. Step 9, train users, managers, and technical staff in policies and procedures that we have developed. Step 10, implement the Step 10, implement the technical strategy and security procedures. That can only really be done after buy-in and training. Step 11, test the security and update if necessary, or if there's any problems that are found. Step 12, maintain security. I like to also think that maintain security is sometimes test and update as necessary as part of the regular maintenance. So, what are some network assets? Network assets could be any hardware, software application, data requirements, intellectual property, secrets, or even could be the company's reputation. All of those are components of a network asset, or assets for an organization. So what do we mean by security risks? It could be as simple as hacked network devices. What data can be intercepted? How can we analyze, altered, or deleted? Could there be something in place to prevent that? A great example that I've just ran into, at my day job, we've been talking about how to implement ARP poisoning and how simple it is to actually do ARP poisoning. And so we know that those types of devices could be hacked. We've been looking at ways to mitigate that risk. For example, dynamic ARP inspection, DAI. However, we don't run DAI. Even though we've been able to show how easy it is to use ARP poisoning, our network engineers viewed the risk of ARP poisoning as so low that we should not have to worry about it. Other security risks could be reconnaissance, or other types of DOS or DDoS type attacks. Also, could be man-in-the-middle attacks. Because we already talked about data intercepted, analyzed, and altered, what about data integrity? Those are all good risk factors to think about. Risk trade-offs. So within any form of security, we have trade-offs. The trade-offs between the security goals and other goals. For example, affordability. Let's make things super secure, but can we afford to? That's always a fun one. Usability. If we make it so tight, so secure, is it still usable? What about performance? Realistically, if we make our VoIP so secure yet we're not able to make phone calls, does that defeat the purpose of that technology? Next, availability. That's pretty straightforward. We need to have our resources available, but if we make it too secure that nothing is available, we're not meeting our security goal. Lastly, manageability. That's pretty straightforward. So an example of a trade-off is that the security can reduce network redundancy. If all network traffic must go through an encrypted device, for example, we may have one firewall, and that becomes a single point of failure. That defeats the purpose of being secure. Next, security plan. A security plan is normally a high-level document that proposes that an organization is going to do to meet specific security requirements. That could also include times, duties, people, and resources that may be required to develop the policies and how those policies will achieve the implementation of those policies. How could those policies and the implementation of those policies also meet the overall security goal or objective that our plan is supposed to be meeting? Security policy. Per one of the RFCs, RFC 2196, a site security handbook, is a security policy is a formal statement of the rules by which people who are given access to an organization's technology and information assets must abide. But at the same time, we actually have to have a site security handbook, and most organizations don't. Most organizations have a written policy, for those that do, but they're not enforceable, or they're not enforced. So, a policy should address the access, accountability, authentication, privacy, and technologies, but should also talk about things like enforcement. How are we going to enforce our policy? Us having a rule but never enforcing it does no good for that rule. Security mechanisms could be our AAA, authentication, authorization, accounting, could also be physical access, for example, access control, or magnetic locks or locking doors. Could also be technology assets like data encryption, filtering software, firewalls, IDSs/IPSs. Those are all good ones. So, let's talk about encryption for a second. Since we already talked about our AAA, what about our CIA? Confidentiality, integrity, and availability. How do we know that our data is going to be encrypted? This could be a public and private key system, or PKI system. We encrypt data between our hosts. That way, one has a private key, one has a public key, and that data is going to be encrypted in transit. And you use the traded keys, the public keys, to decrypt the data. That's always a good way to verify that data being transmitted will not be able to be compromised, thus confirming the confidentiality of the message as well as the integrity of the message. So how do we modularize our security design? First, it has to be a multi-layer approach. You cannot have a single layer. So we built multi-layers into our security so that if one layer fails, there's another layer that you still have to penetrate. Built-in suspenders approach, pretty much you don't get caught with your pants down. You have plenty of layers to provide overall protection. Part of that modularizing our security design involves securing all the components. That means our network connections, our public servers, and e-commerce services. Could be, are they part of the network? Are they part of the DMZ? Where do they belong? That talks about encrypting or securing our remote access and our VPNs. anything that's getting into our network should be monitored, should be secured. Also, what network services are required to run? If they don't have to run, are they being ran? If they are a key component to our network services, are they being secured appropriately? What about the servers? Are the servers being verified and secured? End users. Are user services being secured, both by technical support staff securing the services that our users may need, but what about our users as a service? Are our users being trained in the way of our security policy? One of the next big things is wireless. Is our wireless secure? So Cisco does have a Cisco Safe Security Reference module that does address security in every modular of a modular network architecture. That way, using this older plan, you can actually secure each area. So, first one, securing internet connection. That could be physical security, that could include firewalls and packet filterings, AAA, authentication, authorization, availability, could also be auditing of logs. Well-defined exit and entry points into the facility, into our network equipment, as well as are our routing and switching protocols secured. That's always a big one because many organizations fail to do that. Securing our public resources. For example, securing service in a DMZ, running firewalls on the servers themselves, as well as a dedicated device, using reliable and up-to-date security operating systems that are up to date on their security patches. Security experts recommend that FTP services not run on the same server as web services. It just happens to be that FTP users have more opportunities for reading and possibly changing files than web users do. There are hacks out there that allow FTP users to escalate their privileges on a web server. So those are things to consider. Security topology. Making sure we have the appropriate services as appropriate machines. Web, file, DNS, mail servers. Are they all on one server or are they separated? Not so much virtual versus physical servers, but is there a virtual machine for each one of these services? Is there a physical server? Should it be this type of flat file system as opposed to this one? Our DMZ is tied off of our firewall, and that's its own little branch. It's just like the rest of our enterprise network is. And even here, there may be a dual firewall put in place. So there could be a firewall in between the router and the internet, then the router, then another firewall between the DMZ and the internet. Cisco loves to put firewalls in very key areas. Next, securing our remote access. Again, that's physical security, as are protecting our firewalls, our VPN servers, other remote access devices, could be one-time tokens, could also be security protocols like CHAP, or Radius or Tactus. AAA is also brought up again here. Physical security is going to be in a lot of these areas, but verifying that each area has the appropriate security measures to protect them. Securing network services. Treat each network device as a high-value host and harden it. Pay attention to which device you're using default passwords and get rid of them. How are you securing connecting to those devices? Are you allowing Telnet? If not, are you allowing for secured SSH? Change the welcome banner to the appropriate less welcome banner. Like authorized access only. Securing our server farms. Is there firewall? Is there an IDS/IPS monitoring the servers? Are the servers kept up to date? Are the accounts appropriate? Are there weak passwords on those servers? Those are all things to consider. What about securing user services? That could also include things like applications. Are the PCs having a firewall ran on them? Are the antiviruses running and active and up to date? How well are the antiviruses to begin with? Here we could also implement a written policy that specify how the software is installed, as well as what software is installed. If we're worried about physical security on our user services, we could consider 802.1x port-based security on our switches. That way, port security could control port access to our individual devices. What about securing our wireless network? That could be as simple as setting the wireless on their own VLAN or subnet, simplifying the address, making them different addresses, filtering, adding in a radius server for authentication of wireless users, require all wireless laptops to run personal firewalls, or also include antiviruses. Both Windows, Microsoft products, and Cisco have NAC, Network Access Control, or NAP, Network Access Protection, so that if a wireless device gets on the network, and they'll verify the personal firewall and antivirus is up to date. If not, they get placed into an appropriate VLAN to reduce the risk of security. Not a lot of companies that I've ran into use NAC or NAP, but those are all key things in securing wireless security. That could also be wireless security, as in what wireless encryption are they running? Are they running WEP? Are they running WPA? WPA2? Is the WPA or WPA2 personal or enterprise? Is radius tied here? That's all big other things. WEP is poor, but if that's what you have, it's better than nothing, but it's pretty weak. You can Google how to break WEP encryption and break WEP encryption within a few minutes. WPA2 is a nice alternative. Normally it uses Advanced Encryption Standard, AES, which is a 256-bit key. This is better. However, it's not as good as WPA2, and WPA has already shown you could break into it 20-30 minutes. Part of this could also be including EAP, Intensive Authentication Protocols. That so we can couple our 802.1x with our EAP. This allows us to run things like radius, forcing our wireless clients to authenticate against our radius server. That way, we could pass credentials from our wireless access, from our wireless users, to our wireless access control, to a server running our radius server. That way they could pass the credentials and verify if they're allowed on the network. If that's too protocol heavy, Cisco has a lightweight EAP that allows for mutual authentication. That way the user and the access point must be authenticated. That way you can verify that you're truly authenticating your wireless user against the appropriate Cisco device that is then authenticating against the appropriate radius device. There are plenty of other EAP types out there, but Cisco and Microsoft really push the LEAP and PEEP, the protected EAP, And all of that is encrypted traffic to the Radius server. We could also talk about the VPN software on our wireless clients. If we're already assuming that our wireless clients are secured, what about the VPN software on the wireless clients? Are they secure? Are we verifying that passwords and credentials aren't being saved? That's part of the VPN security. And that's actually a key thing here. VPN security to verify that our mobile users are tunneling into our network so that they can securely transmit and receive sensitive data, or just data in general. That's actually it for Chapter 8. So I hope you guys took here security plans, policies, and procedures, and the different mechanisms for keeping them in place. I wanted to thank you and hope you guys have a great day.